Hello. All right. Today is day 20 and it leads into day 21. It's for your April 23rd and April 24th assignments. All right, so hopefully you have your notes available to you as well as you have your textbook. In your textbook, we're going to be looking at pages 379 and 392 for extra examples if you feel that you need that, and your vocabulary should be on those pages. All right, so with this section, just like videos currently, you'll notice we're going to jump to a video I've already made, but I wanted to introduce some information to you first. So with today's section, we're going to be factoring a polynomial using a greatest common factor. So I want you to remember what a greatest common factor is. If I have two numbers or if I have two variables, it means that both of those terms, whether it's the numbers, the variables, or the mixture of both, they have a number that can divide from both of them because those numbers can multiply to get what you have. So let me show you what I mean. If I gave you these two numbers, 24 and 36, and I asked you to think of the greatest common factor, we would have to think of the factors per number. All right, so the factors for 24, we could have 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then we would start going backwards again to have 6 and 4, so on and so forth. And then for 36, we would have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, and then again we would start going backwards so we don't have to really rewrite all of those extras. Now, if I want the GCF, okay, I'm looking out of these numbers what the greatest common factor is. So these are all the factors in each of these numbers. These are all the numbers that can divide 24, that can divide 36, because these are the numbers that can create 24 and create 36 using multiplication. Therefore, they can divide into them. All right, so what I'm looking for is not just a factor that they have in common, but the largest number. So as I look, I can see that I have 124, and what I'll come to conclude is that 6 and 6 are the greatest numbers from both 24 and 36 sets of factors that can divide both of them. Therefore, the GCF would be 24 and 36. The GCF would be 6 of 24 and 36. Sorry about that. So what I'm getting at here is I've found that my GCF of both of those numbers is 6. So in this section, you're going to look for your GCF, and then you're going to factor out the GCF. So let me show you what I mean by that. If I had 24 minus 36x, and I know that the GCF is 6, I'm going to take 6 out of each one of those numbers. I'm going to divide both of those by 6. Therefore, I would have 6 on the outside. 24 divided by 6 would be 4. 36 divided by 6 would be 6 with that x. Therefore, I just factored out a GCF. Not too bad, right? All right, so in this section, again, you are going to be given polynomials, and you are going to factor out the GCF. The GCF can be just a number, but it can also be a letter. So if this 24 happened to have an x as well, that means that I could have factored out an x as well as the 6. All right, in this next video, we'll go over that a little bit better. All right, so look over those notes while you're taking or while you're watching the rest of this video. There are some practice problems in the textbook for you, and then I'll tell you about your assignment after you watch this video. So we are going to factor polynomials using a greatest common factor. So let me start by writing out the polynomial from your notes. And then remind ourselves what a greatest common factor is, and then apply that to this, which I just realized is kind of crooked. All right, so hold that thought. All right, I'm back. He was getting pretty noisy with the squeaky toy, so we had to take it away. All right, so right now, I have 16y cubed z squared plus 24y squared. And we're going to factor out the greatest common factor. So let's remind ourselves what the greatest common factor of any number is. So the way you learned in middle school, and we talked about this in other units, is the greatest common factor is the largest number or the largest variable that can divide whatever term you have. So if I'm asking for you to factor an entire polynomial by the greatest common factor, it means that it's something that can be pulled from both the first and the second term, or if it's a greater polynomial, meaning it's not just a binomial, if it was a trinomial and it had 4 terms, 5 terms, whatever the GCF is, it can be pulled out, it can be factored out of every single term within the polynomial. So in your notes, I gave you 3 steps, and I'm going to utilize these steps going through what's on your notes with the same problem that you had. So step 1 says we're going to factor out the greatest common factor of our coefficients. So our coefficients are 16 and 24. If I wanted to look at the factors of those 2 numbers, and this will go away in just a minute, the factors of 16 are 1 and 16, 2 and 8, 4 and 4, and then I start going backwards, listing the same exact coefficients as I had from the top. All right, so now let's look at 24. My factors of 24, I have 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then my next listed would be 6 and 4. So I don't have to really list anything past that because I've already listed all those sets of factors. So it sounds like my dog's going to pick all of the noisy toys this time, and I apologize. All right, so looking at our sets of factors, let me erase what I don't really need to look at here. Ollie. All right, so I want to figure out the biggest number that I see on both of my lists, which obviously the biggest number here is 16. I don't see that over here, and then 24, so on and so forth. So you all should quickly be able to find that 8 is the greatest common factor between 16 and 24. So step 1 is identifying just what we did here. Now, do you have to write out your factor trees? Absolutely not. But if it helps, just write it on the side of your paper. All right, so step 1 is finished. I have that 8 is the greatest common factor of the coefficients. Now, I'm going to look at every single variable I have, and this leads me to step 2, which is factor out the common variables. Now, we have to consider the fact that our variables, we don't necessarily know what they represent, but we can still factor them out by the said variable. So right here for y cubed, we can go ahead and say that we know this is y times y times y. And then when I have my other y, which is y squared, I have y times y. So when I'm factoring out a variable, I'm going to look to see what the smallest amount is, and that's the greatest common factor, because I have y times y in y squared, and I also have it in y cubed. I just have something left over, and that's perfectly fine. So, concerning your variables, you first look at your same variables. It doesn't mean that it has to be a like term, because these clearly aren't like terms, they're just a like variable. And whatever the most amount is that you can factor out is the smallest amount of that variable in either one of your terms, because after y squared, there's nothing here, therefore it's run out. It's okay that this one has leftovers. All right, so one more thing. We can see that there's a z squared here, and there's not any z squared on my second term. That's fine. We just don't take out any z. It doesn't factor out. All right, so let me pull that computer back up. All right, my step 1 is the 8. My step 2, I factored out the variable. My step 3 is to actually factor this GCF out of the entire polynomial. So we'll be doing our division. All right, so 16 divided by 8 would be 2. And then if I did y to the third power divided by y squared, think about your quotient of powers property. That means I would just subtract my exponents, or think about that factoring as well. I had 1 left over. And then z squared. Sorry about that. All right, so my first term is finished. Now let's look at my second term, which is the 24. All right, sorry about that. So let's look at the second term. I have 24 divided by 8, which would give me 3. And then I have y squared divided by y squared, which means it's canceled out. So my second polynomial, excuse me, my second term in the polynomial has been factored. All right, now at this point I've gone through all 3 of my steps, and if this happened to not be in standard form, the polynomial within, you would straighten it up, but it should already be there. All right, so I'm going to box that answer. All right, so you factored out your GCF of your polynomial. You're good to go now. All right, so let me erase this. And then in your notes, I gave you an extra example. I'm not going to go over that again with you. What I'll do instead is pull your assignments. Sorry if that paper sound is loud. So your assignment was the self-checking paper, Why Didn't the Piano Work? Which was this right here. All right, so if I wanted to go over another example with you, I would pick something in set 4 just to make sure that you were good to go, because those are a little bit more complex. All right, so let me pick, I'll pick letter C. So again, this is in set 4, and it's letter C. In letter C, I have 15 x cubed y minus 35 x squared y squared plus 40 x y cubed. All right, so we're going to go through those 3 steps just like our notes say. We are going to find the GCF of the coefficients, and then we're going to find the GCF of each individual variable, and then finally we're going to factor out whatever that GCF is from the given polynomial. All right, so I have 15, negative 35, and positive 40. So when I factor this out, I need to also consider that this is negative. When I factor something out, this should still remain minus or negative whatever value I have. And I say that because if all of these happen to be negative, then yes, you'd go ahead and factor out a negative, but this is not that problem. All right, so I have 15 as my smallest number. So that's where I'm going to pull my factors from. So my factors of 15, I have 1, 3, 5, and 15. All right, so starting from the largest number, 15 cannot evenly divide 40. Therefore, that's out of the picture because it has to get all three. Then 5, we know these are all multiples of 5, so 5 would be the GCF of the coefficient. All right, so I have that. Now let's look at our variables. I have an x and a y in each one, so I should be able to factor out some of x and some of y. So starting with x, I can see that I have 3 x's here, I have 2 x's here, and I have 1 here. So I can only factor out the smallest amount, which is just my 1x. So the GCF of all of these terms of x is just x. All right, so then we'll do the same thing for y. I have y to the first power, I have y squared and y cubed. So again, the smallest amount is your greatest common factor. All right, so now let's go and factor that amount out. So 15 divided by 5 produces 3. X cubed divided by x to the first power, we subtract those exponents, so I get x squared. My y divided by y, there's nothing left. So let's skip to our next term. I would have 35 divided by 5, which produces 7. X squared divided by x, which is x. Y squared divided by y, which is y. Almost finished. I have one more term. 40 divided by 5 is 8. X divided by x is not, well, it's 1, excuse me, so we don't have to write that. Y cubed divided by y would be y squared. Let's try that again. All right. And if we look, that would be the letter W. So now I'm just going to circle or box my answer, and I am good to go. All right. So at this point, we've finished some of the notes from day 7. I hope that this made a little bit more sense to you with the given explanation. All right, so you watched the instructional video. You should feel pretty comfortable in what you're doing. So your assignment is this handout. It's a self-checking handout. There are a good amount of problems on it, so you should get plenty of practice. And you have 2 days to take care of it, so you should be okay with that. Now, if you feel like, hey, I could use a little bit more practice, or I want to start off with some problems that are a little bit easier before I get to that, I have provided you one of your maze papers. I think I might have called it a scavenger hunt on your task by mistake, but it's just one of the mazes, and it's self-checking. This would be a good start if you feel like you need a little bit of extra practice before you get to the assignment that will be turned in. This you don't have to turn in. All right, so you don't have to do this, but if you want to, take care of it. All right, so I think that's it. Again, I hope you guys are doing well. I miss seeing you, and hopefully I will get to talk and see you soon.